We're now on Learning Target 1.7. I know average atomic mass and how it is organized in the periodic table. So let's look at a specific question. So what is the average atomic mass and identity of the element that has the following stable isotopes? So remember, isotopes are atoms that have different amount of neutrons. Since they have a different amount of neutrons, they also have a different mass. So what we know is the percent abundance and the mass of 3 specific isotopes of a certain element. We don't know the element. We're asked to identify the element and its average atomic mass. So the average atomic mass is the average of all 3 isotopes, isotope 1, 2, and 3, but it's not just a straight average. I know it says average, but it's kind of a weighted average. I mean, it is a weighted average. So if you've ever talked about weighted averages in math class, that's what this is. It's also kind of like your grades. You take a class and you have 1 homework assignment and 1 test in your class. Which homework or which assignment do you think is worth more points? The test. The test will be worth more points because it's more important. It is more heavily weighted. Kind of like this. So which of these isotopes is more heavily weighted? Isotope 1. Isotope 1 has the biggest percent abundance, meaning it's the one that's around more, compared to isotope 2 and isotope 3, which don't have quite as high a percent abundances. So the question is, how do we find the average atomic mass? Okay, well, there's a general formula for this, and it is the percent abundance times the atomic mass. So percent times mass. Okay? But the percentage, there are 2 ways to deal with a percentage when you're multiplying it. The first thing you can do is when it's all at the very end, you can divide everything by 100, or you can convert the percentage into a decimal first. So there's 2 ways to do it. I'm going to convert the percentage into a decimal first, okay, by moving the decimal 2 spots over. So let me show you what this looks like. So the first percent abundance I have is 78.90%. So I'm going to convert that to a decimal by writing 0.789, and then I'm going to multiply that by my atomic mass, which is just 23.985 AMU. That is my first isotope. Then I'm going to add that to my next isotope. But first I got to do the percent abundance, which is 10%. So I'm just going to write it as it is. So I'm going to move the decimal 2 spots to the left. And I get that, and I multiply by my mass, 24.986 AMU. And then I have to add my last decimal, or my last isotope, which is 0.1110. That is, again, my percentage converted to a decimal. And the easiest way to do that is just move the decimal point 2 spots to the left. What you're really doing is dividing by 100, but we can do this in our head. And then I'm multiplying that times, where's my x? Times the mass, which is 25.983. Get my equal sign on there. So if you don't understand what I did there, maybe rewatch that portion. So again, my percentage in decimal form times my mass. And that's all of my first one. And then my second one is for my second one. And then my third one is for my third one. So when I multiply all this out, I get 24.307 after I round everything, AMU. So that's my average atomic mass. Then I look up at the periodic table, and I can say, since I got such a close number to magnesium, which is has the atomic number of 12, I can safely assume that this data represents magnesium, so Mg. So there are my final answers. So the individual example goes as follows. The element europium was discovered by a French chemist in 1890 and was named after the continent of Europe. There are 2 naturally occurring isotopes of europium. Their atomic masses and percent abundances are given below. Calculate. Don't forget to show your work. The average atomic mass of europium. So I'll pause the video, or you can pause the video here, work on it, and then see if you get what I get. Okay, so I'm going to work out this example. Again, knowing that percent abundance in decimal form times my mass will get me my average if I add it to another one. So plus my second percent times my mass plus a third or fourth percent will get me my abundance. So my percent in the beginning is 47%, which I'm going to change to 0.4780%. Multiply that times 150.92. And I'm going to add that to my second isotope, which has a percent abundance of 52%, which I'm going to again change to decimal form of 0.5220 times 152.92. Make this a little bit bigger. So that's what I have. So 0.478 times 150.92 plus 0.522 times 152.92, and then I'll get my answer. So after I do all of that, I get an average atomic mass of 151.96 AMU. So that is what you should get.